Structural minimum thickness. Minimum required thickness without corrosion allowance based on mechanical loads other than pressure that result in longitudinal stresses. See 7.6. The thickness is either determined from a standard chart or engineering calculations. It does not include thickness for corrosion allowance or mill tolerance. Temporary repairs. Repairs made to piping systems in order to restore sufficient integrity to continue safe operation until permanent repairs can be scheduled and accomplished within a time period acceptable to the inspector or piping engineer. Injected fittings on a valve to seal fugitive emissions from valve stem seals are not considered to be a temporary repair as described in 8141 and 815 of this code. Testing. Procedure used to determine pressure tightness, material hardness, strength, and notch toughness. Example, pressure testing, whether performed hydrostatically, pneumatically, or a combination of hydrostatic, pneumatic, or mechanical testing. Testing does not refer to NDD using techniques such as PT or MT, etc. Tank farm piping. Process piping inside tank farm dikes are directly associated with a tank farm. Utility piping. Non-process piping associated with a process unit. Stream, air, water, nitrogen, etc. And then you got your acronyms: API, ASME, ASMT, AUT, BPVC, CMB, CML, CP, CUI, EMAT, ESCCC, ET, FFS, FRP, GWT, HIC, ID, ILI, IOW, ISO, LDAR, LT, MAT, MAWP, MAD, MT, MDR, MFL, MOC, MT, MTR, NACE, NDE, NPS, OD, OSHA, PAUT, PCC, PEC, PMI, PQR, PRD, PRT, PT, PWHT, RBI, RFID, RT, RTP, SAI, SCC, SMB, SBP, SDO, ST, SMYS, TML, UT. 4. General User Inspection Organization. 4.1. General. An owner user of a piping system shall exercise control of the piping system inspection program, inspection frequencies, and maintenance, and is responsible for the function of an authorized inspection agency in accordance with the provisions of API 570. The user-owner inspection organization also shall control activities relating to the rating, repair, and alteration of the piping systems. See definition of authorized inspection agency. 4.2. Authorized piping inspector qualification and certification. Authorized piping inspectors shall have education and experience in accordance with Annex A of this inspection code. Authorized piping inspectors shall be certified in accordance with the provisions of Annex A. Whenever the term inspector is used in this code, it refers to an authorized piping inspector. 4.3. Responsibilities. 4.3.1. Owner-user organization. 4.3.1.1. System and procedures. An owner-user organization is responsible for developing, documenting, implementing, executing, and assessing pipe inspection systems and inspection procedures that will meet the requirements of this inspection code. These systems and procedures will be contained in Quality Assurance Inspection Repair Management System and shall include A. Organization and reporting structure for inspection personnel, B. Documenting and maintaining inspection and quality assurance procedures, C. Documenting and reporting inspection and test results, D. Developing and documenting inspection plans, E. Developing and documenting risk-based assessments, F. Developing and documenting the appropriate inspection intervals, G. Corrective action for inspection and test results, H. Internal auditing for compliance with the Quality Assurance Inspection Manual, I. Review and approval of drawings, design calculations, and specs for repairs, alterations, re-ratings, and fitness for service assessments, ensuring that all jurisdictional requirements for piping inspection, repairs, alteration, re-rating are continuously met. Reporting to the authorized piping inspector for any process change that could affect piping integrity. I. Training requirements for inspection personnel regarding inspection tools, techniques, and technical knowledge base. Controls necessary so that the qualified welders and procedures are used for all repairs and alterations. Controls necessary so that qualified NDE personnel and procedures are utilized. Controls necessary so that only material conforming to the applicable section of the ASME code are utilized for all repairs and alterations. Controls necessary so that all inspection, measurement, and test equipment are properly maintained and calibrated. Controls necessary so that the work of contract inspection and repair organizations meet the same inspection requirements as the owner-user organization in this inspection code. Internal auditing requirements for the quality control system for pressure relieving devices. S. Controls required to ensure that the inspector has the visual acuity necessary to perform their assigned inspection tasks. 4312 Inspection Organization Audits. Each owner-user organization should be audited periodically to determine if they meet the requirements of an authorized inspection agency as defined in this inspection code. The audit team should consist of people experienced and competent in the application of this code. The audit team should typically be from another owner-user plant site, company central office, or from a third-party organization experienced and competent in refining or petrochemical plant process inspection programs, or a combination of third-party and other owner-user sites. The following key elements of an inspection program should be assessed by the audit team. A. The requirements and principles of this inspection code are being met. B. Owner-user responsibilities are being properly discharged. C. Documented inspection plans are in place for covered piping systems. D. Intervals and extent of inspections are adequate for covered piping systems. General types of inspections and surveillances are being adequately applied. Inspection data analysis, evaluation, and recording are adequate. Repairs, re-rating, and alterations comply with this code. The owner-user should receive a report of the audit team's scope and findings. After review of the report, non-conformance should be prioritized and corrective action implemented. Each organization should establish a system for tracking and completion of audit findings. The information should be reviewed during subsequent audits. 4313 MOC. The owner-user is responsible for implementing an effective MOC process that will review and control changes to the process and to the hardware. An effective MOC process is vital to the success of any piping integrity management program in order that the inspection group is able to 1. Address issues concerning the adequacy of the pressure piping design and current conditions for the process changes. 2. Anticipate change in corrosion or other types of damage and their effects on the adequacy of the pressure piping. And 3. Update the inspection plan and records to account for those changes. The MOC process shall include the appropriate materials, corrosion experience, and expertise in order to effectively forecast what changes might affect piping integrity. The inspection group shall be involved in the approval process for changes that may affect piping integrity. Changes to the hardware and the process should be included in the MOC process to ensure its effectiveness. 4314 IOWs, Integrity Operating Windows. The owner-user shall implement and maintain an effective program for creating, establishing, and monitoring integrity operating windows. IOWs are implemented to avoid process parameter exceedance that may have an unanticipated impact on pressure equipment integrity. Future inspection plans and intervals have historically been based on prior measured corrosion rates resulting from past operating conditions. Without an effective IOW and process control program, there often is no warning or changing operating conditions that could affect the damage mechanisms and rates and subsequently impact the integrity of equipment and or validation of the current inspection plan. Deviations from and changes to trends with established IOW limits should be brought to the attention of inspection engineering personnel so that they may be modified or created a new inspection plan depending upon the seriousness of the exceedance. Integrity operating windows should be established for process parameters, both physical and chemical, that could impact equipment integrity if not properly controlled. Examples of the process parameters include temperature, pressures, fluid velocities, pH, flow rates, chemical and water injection rates, levels of corrosive, erosive constituents, chemical composition, etc. IOWs for key process parameters may have both upper and lower limits established as needed. Particular attention to monitoring integrity operating windows should also be provided during startup shutdowns and significant process upsets. See API 584 for more information on issues that may assist in the development of IOW program. Piping engineer. The piping engineer is responsible to the owner user for activities involving design, engineering, review, rating, and analysis or evaluation of piping systems and PRDs covered by API 570 as specified in this code. Repair organization. All repairs and alterations shall be performed by a repair organization as defined in Section 3. The repair organization shall be responsible to the owner user and shall provide materials, equipment, quality control, and workmanship necessary to maintain and repair the piping system in accordance with the requirements of API 570. Authorized piping inspector. With inspections, repairs, and alterations being conducted on piping systems, the designated authorized piping inspector shall be responsible to the owner user for determining that the requirements of API 570 on inspection, examination, quality assurance, and testing are met. The inspector shall be directly involved in inspection activities, which in most cases will require field activities to ensure that procedures are followed. The inspector is also responsible for extending the scope of inspection with appropriate consultation with engineers and specialists, where justified depending upon the findings of the inspection. Where nonconformances are discovered, the designated inspector is responsible for notifying the owner user in a timely manner and making appropriate repair or other mitigative recommendations. The inspector should be knowledgeable of piping systems, damage types listed in API 571 and the content of API 574, 576, 577, 578, 583, 584, and also knowledgeable in API RP 580, where RBI is used. The inspector shall be to use the guidance contained in these RPs to meet requirements or expectations in this code. The authorized piping inspector may be assisted in performing visual inspections by other trained and qualified individuals who may or may not be certified pipe inspectors. Examiners and operating personnel performing NDEs shall meet the qualifications identified in 435, but need not be authorized piping inspectors. However, all examination results should be evaluated and accepted by an authorized piping inspector. See definition of an authorized piping inspector. 435, examiners. An examiner shall perform the NDE in accordance with job requirements. See definition of an examiner. The examiner is not required to be certified in accordance with Annex A and does not need to be an employee of the owner user. The examiner shall be trained and competent in the NDE procedure being used and may be required by the owner user to prove competency by holding certifications in those procedures. Examples of those certifications that may be required include ASNT, SNT, TC1A, ASNT, CP189, and AWS QC1. Inspectors conducting their own examinations with NDE techniques shall be appropriately qualified in accordance with owner-user requirements and appropriate industry standards. The examiner's employer shall maintain certification records of the examiners employed, including dates and results of personnel qualification. These records shall be available to the inspector. 436. Other personnel. Operating, maintaining, maintenance, engineering, process and mechanical, or other personnel who shall have specialized knowledge or expertise related to the particular piping system shall be responsible for timely notification to the inspector or engineer of issues that may affect the pipe integrity, such as the following: any action that requires MOC or inspection activity as a result of an MOC. Operations outside defined integrity operating windows. Change in source of feedstock or other process fluids that can increase process-related corrosion rates or introduce new damage mechanisms. Piping failures, repair actions conducted, and failure analysis reports. Cleaning and decontamination methods used or other maintenance procedures that could affect piping and equipment integrity. Reports from other plant experiences that have come to their attention regarding similar service piping and associated equipment failures. Any unusual condition that may develop: noise, leaks, vibrations, movement, insulation damage, external piping deterioration, support structure deterioration, significant bowling corrosion. Any engineering evaluation, including FFS assessments that might require current or future actions to maintain mechanical integrity until next inspection. Section 5. Inspection, examination, and pressure testing practices. Inspection plans. Piping systemization and circuitization. In order to develop inspection plans, including scope, frequency, techniques, and locations, facility piping should be broken down into piping systems and circuits. Piping systems can be defined at a PFD, process flow diagram level. However, piping circuits are often defined at the PID, process instrument diagram level. Potential damage mechanisms are primarily a function of the process operating conditions, the material of construction, and of mechanical design. Defining systems and circuits based upon potential damage mechanisms yield an inspection plan with a high probability of detecting damage. The pipe systemization is the first cut for defining the potential corrosion issues and is a convenient reference to the general location and damage mechanisms within the process unit. Piping systems generally have common characteristics such as one or more of the following: process intent, overhead reflux system, process control scheme, temperature endpoint, process stream composition, design operating conditions, similar or related sets of IOWs. Piping systems may contain or pass through one or more equipment items, exchangers, pumps, and will typically contain one or more piping circuits. Piping systems and circuits developed from expected identified damage mechanisms enables the development of concise inspection plans and forms the basis for improved data analysis. Piping circuitization is further broken down of piping systems in the section of piping or individual pipe components which have damage mechanisms, same material of construction, that have similar damage rates and modes. Refer to API 574 for more information on the development of piping systems and circuits. 512. Development of piping inspection plans. An inspection plan shall be established for all piping systems or circuits and associated pressure relieving devices within the scope of this code. The inspection plan shall be developed by an inspector or engineer. A corrosion specialist shall be consulted to identify, clarify potential damage mechanisms and specific locations where degradation may occur, especially where localized corrosion or cracking mechanisms can be involved. A corrosion specialist should be consulted when developing the inspection plans of piping systems that operate at elevated temperatures above 750, and piping systems that operate below the ductile to brittle transition temperature. Special attention in the inspection plan should be given to any type of deterioration or issues listed in 552. An inspection plan is developed from the analysis of several sources of data, including piping and inspection records. Piping systems shall be evaluated based on present or possible types of damage mechanisms. The methods and the extent of NDT shall be evaluated to ensure that they can be adequately identified the damage mechanisms and the severity of damage. Subdividing piping systems into circuits subject to common damage mechanisms facilitates selecting the inspection techniques best suited to find the damage and that's most likely to occur in the piping system. Examinations shall be scheduled at intervals that consider the type of damage, see API 571, rate of damage, progression, tolerance of the equipment to the type of damage, capability of the NDT method to identify the damage, maximum interval as defined in codes and standards, extent of damage, recent operating history including IOW's exceedances, MOC records that may impact inspection plans, RBI assessments or piping classification. The inspection plan shall be developed using the most appropriate source of information, including those referenced in Section 2. Inspection plans shall be reviewed and amended as needed when variables that may impact damage mechanisms or deterioration rates are identified, such as those contained in inspection reports or management of change documents. See API 574 for more information on development of inspection plans. 513. Minimum contents of an inspection plan. The inspection plan shall contain the inspection tasks and schedules required to monitor identified damage mechanisms and ensure the pressure integrity of the piping system. The plan should define the type of inspection needed, internal, external, on-stream, non-intrusive. Identify the next inspection date for each inspection type. Describe the inspection methods and NDT techniques. Describe the extent and locations of inspection and NDT at CMLs. Describe the surface cleaning requirements needed for inspection and examinations for each type of inspection. Describe the requirements of any needed pressure test, type of test, test pressure, test temperature, and duration. Describe any required repairs if known or previously planned before the upcoming inspection. Describe the types of damage anticipated or experienced in piping systems. Define the location of the inspected damage. Define any special access and preparation needed. Generic inspection plans on industry standards and practices may be used as a starting point in developing specific inspection plans. The inspection plan may or may not exist in a single document. However, the contents of the plan should be readily accessible from inspection data systems.